I'm Lindsay.
The topic that we're discussing is magnetism. First, we're going to give you a brief introduction of magnetism. We're going to start by defining magnetic force. Magnetic force is the attractive or repulsive force between two poles of a magnet. Poles of the magnet is the region in the magnet where the magnetic field is the strongest. So here you see that like poles repel, just like these magnets. They repel. And opposites pole attract. Next, we're going to define magnetic field. It's the region around the magnet that is affected by the magnetic forces. So this shows how it gets stronger towards the poles. So the magnetic field is stronger towards the South Pole or towards the North Pole. Our complex question is, what variables affect the magnetic force?
For our experiment number 1, our question was, how does a magnet interact with different materials? Our claim was that magnets will attract materials or objects made of metal. So, what we used was a pop can, plastic cup, staples, a key, some paper clips, a ruler, and a whistle. So we took our magnets. This doesn't attract. The whistle doesn't attract, but that part, the rings do. The paper clips attract. The key does not. Staples attract. The pop can doesn't, and the plastic cup doesn't. We found that the magnet only attracted the metal objects, but it did not attract all metal objects. So our evidence supports our claim, but there may be other variables to consider.
To conclude our first experiment, we found that the magnet did not attract all metal objects, and this is because magnets only attract certain types of metal, such as iron, cobalt, and nickel. The reason why magnets are attracted to iron, cobalt, and nickel is because those three types of metals have extra electrons, and in any other material, the electrons are spinning in different directions and they cancel each other out. But in iron, cobalt, and nickel, the extra electrons are still there after the other ones are all canceled out. So the extra electrons respond to the magnet. So our second experiment, our question was, is magnetic force affected by temperature? Our claim was that the higher the temperature of the magnet, the greater the magnetic force would be. So what we did was we used magnets, we used ice and hair dryers to either heat or cool the magnets. We used a ruler and a scale to measure the magnetic force. Using the scale, we measured the force by placing the heated or cooled magnet above the magnet that was on the scale and measuring the change in weight on the scale. So as we got closer, the weight of the magnet, or the weight of the force, was pushing down on the magnet and increasing its weight and therefore increasing the magnetic force. We took measurements at 6 inches from the table, 5 inches, and 4 inches, and we found that the temperature seemed to have no effect on the magnetic force. Each time we did it, the numbers were pretty much consistently the same for the hot, cold, and the room temperature magnet. To conclude our second experiment, our evidence did not support our claim because the temperature really didn't seem to have an effect on the magnetism in our experiment. However, in our research we found that it actually does have an effect on magnetism. It would just have to be more extreme temperatures in either direction, so really, really hot magnets or really, really cold magnets, to really be able to see a difference.
Our third experiment we did was, our question was, is magnetism affected when tested through different states of matter? The states we used were solid, liquid, and gas. Our claim was the magnetic force will be the strongest through a gas and weakest through a solid. The materials that we used were a scale, magnets, a cup of water, a piece of cardboard, and a ruler. So to test this, first we used air. We put the ruler up to measure how far it is, and we used the same poles so that they would repel each other. So we did it at 4 inches, and we measured how strong the force was through air, and we found that it was 1.9 grams of force. Then we did water. We put a cup of water on the scale, put the magnets in there, and measured at the same distance at 4 inches the force that it had, and we found that it had 7 grams of force. And then we put the magnet on there, and we put a piece of cardboard or the solid in between the magnets, and we measured it at 4 inches again, and we found that it was 1.6 grams of force. We found that our evidence did not support our claim because the magnetic force in water was significantly stronger than in air or the solid. This doesn't support our claim because our original claim, we said that the gas would be the strongest and through the solid would be the weakest, but we found that water was actually the strongest, and the air and the solid, although there was a difference, it wasn't that significant of a difference that we thought it would be. In conclusion to our third experiment, we found that magnetism was actually affected by water more so than it was affected by a solid being in between the magnets or a gas being in between the magnets. A liquid had the biggest effect on the magnet's force. In conclusion to our complex question of what variables affect magnetic force, we found that the temperature of the magnets affect its magnetic force. We found that the state of matter of which the magnets are going through, such as a solid, liquid, or a gas, affect its force. And we found that the material of the object affects whether it has a magnetic force.